Welcome back, geometry students. Mrs. Fellon, we are on lesson 6.4 in your student journals on page 181. We're just going to kind of go over a couple things today, not a whole lot on this video since the last video was so long. So in this section, we are talking about the mid-segment of a triangle. And so we're going to start with kind of the vocab for that, the mid-segment of a triangle. So the mid-segment of a triangle is a segment that contains the midpoints of two sides of a triangle. So I'm just going to write that down for us. So a segment that connects the midpoints of two sides of a triangle. So it's kind of easier to look at this in terms of like a picture, right? So if I have this triangle here, what we know about, and this is like the triangle mid-segment theorem. So DE is the mid-segment of a triangle because it connects the midpoints of line segment A to B and line segment BC. So DE is a mid-segment of a triangle. The catch here is that there can be three different mid-segments of in any given triangle. Because if I found the midpoint, let's say, of A to C and connected D to C, then technically this would be a mid-segment, and then E to C or E to that midpoint would also be a mid-segment. So in any given triangle, you can actually have three separate mid-segments of the triangle. A lot of times what you'll refer this whole, like all three of these mid-segments together is called the mid-segment triangle. And so basically what that means is that it's the triangle formed by all three mid-segments of a triangle. So there's three separate mid-segments and there's one mid-segment triangle, if that makes any sense. A couple pieces of information that I want you to make sure that you are aware. So a couple things. So first of all, the mid-segment is always parallel to the side opposite. So like, for example, D to E and A to C are both marked as parallel. We could also mark, we'll call this, I don't know, M. We can go E to M and B to C is parallel. And then E to M and B to A are parallel. So the mid-segment is always parallel to the third side. In addition, the mid-segment is always half the length of the side that it's opposite. So for example, if I knew that the distance from D to E was, I don't know, 10, then that means if D to E is a mid-segment of the triangle, then A to C would have to have a distance of 20. So D to E is always going to be half of A to C because that mid-segment is always half the distance of the full thing. And so actually what I'm going to do, we're going to do most of this stuff in class, but what I wanted to do is just kind of go through an example of what you will see and then kind of give you a chance to practice it on your own. So the first and foremost it asks, so I'm just going to have you write down this example. It says, find the vertices of the mid-segment of a triangle with the vertices at A, negative 2, 5, B, negative, or positive 2, negative 1, and C of negative 6, 1. So you can start by just kind of sketching a graph, and it's not super important that it's 100% accurate, but you can grab some graph paper if you want. I'm just going to kind of freehand this. So negative 2, 5 is A, 2, negative 1 is B, and negative 6, 1 is C. All right, I'm going to draw in my triangle here. So what I'm going to be doing here is I'm going to be finding the mid-segment of the mid-segment of the triangle. So I'm going to do two different things. I'm going to find the mid-segment that's going to be parallel to side CB. So again, there's three separate mid-segments, right? So I want the one that's parallel to C to B. So I'm going to find the midpoint of A to C. I'm going to find the midpoint of A to B, and then I'm going to connect it, and that's going to be the mid-segment that's going to be parallel to CB. All right, so step one, we're going to find the midpoint of A to C. And so remember, to find a midpoint, you add up your x's. So A is negative, so the x's are negative 2 and negative 6. Divide by 2, and then add up your y's. So 5 and 1 divide by 2. I get an answer of, what is that? Negative 4, 3. So I figured out that this midpoint is at the point negative 4, 3. Next, I'm going to find the midpoint of A to B. And I'm going to do that the same way, except that I'm going to use, obviously, segment A, points A and B. So I'm going to do -2 plus 2 divided by 2. I'm going to do 5 plus -1 divided by 2. So I get the point 0, 2. All right, so 0, 2, this is my midsegment. And so what I figured out there is that's one midsegment of my triangle. If the directions asked you to find the midsegment triangle, the coordinates of the midsegment triangle, what you would then need to do is, since you already have these two midsegment or midpoints, you would need to find the third midpoint. So find the midpoint, in this case, of C to B. So we'll add up the x's, add up the y's, and I get -2, 0. And so now, if I connected all three of those midsegments, right? So all three of them, they form a triangle. That would be what we call the midsegment triangle. So I know in some of your practice, it'll ask you to find just the midsegment of the triangle that, say, is parallel to side CB, for example. And then you would find this midsegment. But if I asked you for the vertices of the midsegment triangle, you would need to find all three midpoints of the triangle sides, and then that would be the segment that you're looking for. All right, that's, like I said, nice and short. That's it. If you have any questions, I would try the practice, and if you have any questions, come see me. All right, bye for now.